Thanks for stopping by to check out this episode of Vintage Audio Review. It's actually the 29th episode, so I thank you for checking it out. In this episode, I'm going to talk about this Carver M1.0t power amplifier. So a few weeks ago on one of the Facebook audio forums that I participate in, someone asked me if I had a Carver M1.0t that could be tested. I said I did not have one, but I would check with my good buddy Ian, episode number 6, to see if he may have something. It turns out that Ian did not have the 1.5T, but he did have a 1.0T that he would let me borrow to test. So here we are. A little bit about the M1.0t. It was made starting around 1986 and sold for approximately $559 back then. It's rated at 200 watts per channel into 8 ohms with 0.15% or less, and it weighs in about 19 pounds. The T designation in the model number refers to the tube transfer function characteristic that Carver gave many of his amps to signify that they were modeled after a tube amplifier. The M1.0t started off as an inverting model in which the right channel was inverted 180 degrees out of phase with the left channel. This was changed and the phase of the left and right channel remained the same, but they did put a stereo mono switch in back so that you could run the amplifier in mono. The Carver M1.0t started off as the Carver M1.0, which was modified by Bob Carver for the legendary Carver Challenge, which I will list a link below in the description for you to read if you so desire. But basically, he modified his M1.0 such that it mimicked a more expensive tube amplifier, and the reviewers were unable to tell a difference for the most part. So the T designation references the tube transfer characteristic of that modified M1.0t. The best as I remember reading about the challenge. So that's kind of a little brief history on the M1.0t. So we're obviously doing a close-up on the front of the M1.0t. We do have our handles here for grabbing them in and out of a rack, your on-off switch. Here is our magnetic field power amplifier designation, and it says high headroom, low feedback power amplifier. Here we have our 7 LEDs. The 6th LED up says 0 dB in the center of it, and the one right above it is a red LED and it says headroom exhausted. It also has 400 watts. So supposedly it's rated at 200, and if you're at the 6th LED you're hitting 200, but it does have peaks that it could go near 400, and then that LED would come on. I never had the red LED come on during my testing. Also, it has a note here that says fault strobe, fault load, loudspeaker protection, and I believe one or several of the LEDs will flash if it gets into a mode that it needs to shut down the amplifier. Obviously, we're looking at the rear of the M1.0t. Right here is the stereo mono switch. You just loosen up the 2 screws and slide the switch over to the position that you want. Here are our unbalanced RCA inputs, our banana jack friendly 5-way binding post. We also have a 10 amp user replaceable fuse, and we have little diagrams that show us how we connect for stereo or how we connect for mono. So if you want to run mono operation, you connect just to the left input and you use the 2 red speaker outputs and flip the switch over to mono. So here is the Carver M1.0t with the cover removed. Right here is our transformer, a magnetic field transformer it's called. Over here are our filter capacitors. The big ones are 6800 microfarads at 110 volts. Over to the sides are our output transistors. There are 5 PNP and 5 NPNs on each side, and you can see the fairly good amount of heat sinking on each side. Now right here it gets kind of interesting. This and this right here, those are mods to solve a problem with a turn off thump that some of the amplifiers were having, and it forced Carver to come up with a mod, and I guess it was either incorporated after the fact or at the factory. I really don't know, but you can tell what they did there. So this is another view of the M1.0t. Here are our 10 output transistors, 5 PNP, 5 NPN. Over here is the power LED indicator board, this little guy right there. Hopefully that shows up. And these are our emitter resistors for the output transistors, at least some of them. And here is just another view of the inside of the 1.0t. There is a power supply circuit board here. This is where most of the rectifiers are located, on this board here. And you can just see another view of the, I believe these are FETs and a couple resistors for the turn off thump mod. And I thought it was worthwhile to point out, this is the inside of the top cover, and right here is some foam that fits right on top of the transformer to help cut some of the noise down. And I did notice this little smoke mark, so at some point something had burned apparently. I couldn't see any damage of anything that had burned, but that is definitely from something burning. So right now the M1.0t is off, and I have the QA402 set to give me about 5 watts into 8 ohms once this thing is turned on. And what I wanted to do is just let you guys see how long it takes for the power to actually come up, because there are no speaker protect relays. It has its own muting circuit. So if you're real quiet, you can hear me click the power button on, which I'll do at the count of 3. 1, 2, 3. So that took about 8 seconds to come up to the 5 watts. What we're going to do now is we're going to turn off the power and see if there's anything unusual going on when the power is off. Remember, there is supposedly a thump that comes on when you turn off the power, and this one has been modified, but we'll just check and see what happens here. So I'm getting ready to turn it off. 1, 2, 3. Okay, it didn't really do much. It stayed at the same level that it was at. There was no peak in anything, and then it dropped off, and here we are with no signal applied, just noise. So our first piece of data is the THD SNR plot at 5 watts into an 8 ohm load, and you can see that the amplifier has about 30 dB of gain, and that's just the normal gain of the amplifier. And we have fairly low THD, 0.00%. That's pretty good. And the SNR is in the 80s. Here we have the frequency response of the M1.0t, and it's down about 0.3 of a dB at 20 kilohertz, and the channel imbalance between the left and right channels is about 0.54 dB at 20 kilohertz, which is about the worst case for this amplifier. So this plot shows THD versus frequency for a couple of different output power levels, and that's into 8 ohms. And the way I do this test is I determine how much power at 1 kilohertz I need to input into the amplifier in order to get the desired power out. In this case, I put X number of dBV in at 100 watts and X number of dBV in to get me 50 watts and so on. And of course, that is not a perfect way to do this test because there is some drop off at the band edges. So I'm not going to get the exact power level out at, say, 20 kilohertz that I do at 1 kilohertz, because the frequency response at 20 kilohertz is down about half a dB or so, depending on which channel. And also the channels are not balanced for this amplifier. So I'm using the right channel's power level to get the determination of my input signal level. And as you can tell, for the most part, this amplifier has a pretty good THD across the different power levels. The left channel does get to about 0.8% THD at 20 kilohertz. The specification was from 20 kilohertz to 20 hertz. It had to have a THD of 0.15% or less, and that was at 200 watts. So we're not at 200 watts for this test, but it gives a pretty good idea that for the most part, this 36-year-old amplifier does a pretty good job of keeping THD down. So here we have the THD SNR plot at 1 kilohertz with the amplifier putting out between 268 to 247 watts into 8 ohms. The THD looks really, really good, 0.03 we'll call it percent, which is better than the 0.15% in the spec, as well as over a 90 dB SNR. And the THD plus noise is in the 70 dB range. So there is a specification for the power at clipping, and that is for a 1 kilohertz signal input, and for the non-inverting model of the M1.0t, of which this is, that is 350 watts per channel. And you can tell that the left waveform is a bit worse than the right waveform, at least as SNRs go, it's 30 dB worse. However, it does have more power, almost 400 watts in 8 ohms, where the right channel is 365 watts into 8 ohms. And the distortion is still measuring less than 0.04%. However, you can tell that there is a lot of harmonics and noise level is creeping up on this unit. And here we have the multi-tone response of the 1.0t looking into an 8 ohm load, and it's showing about 12 bits of distortion-free range. Our last piece of 8 ohm data shows the M1.0t running at 100 watts with a fundamental frequency of 1 kilohertz. And what this shows is a breakdown of the different harmonics. The even harmonics are unlabeled, the first one being H2, which is between the fundamental and H3, and the fourth harmonic would be in between H3 and H5. The odd number harmonics are H3, H5, H7, H9. So it's kind of giving a mixed results. If you look at the left channel second harmonic, it is lower than the left channel third harmonic, but the right channel second harmonic is higher than the right channel third harmonic. So it's kind of mixed results, and this is a new feature of the software that I use for my testing, and I just thought I would show it. It doesn't show a bunch of even harmonics being better than the odd harmonics for sure, which is kind of what you'd expect in most tube amps. So I honestly don't know, after looking at all the data, at least the 8 ohm data, how this is looking like a tube amp transfer function, but I am sure that there is something that I did not measure that might indicate that it does perform like a tube amp. So it turns out I have one more piece of 8 ohm data, and this is the crosstalk, or isolation as I call it, between the left and right channels. And to do this test, I put in a signal to the right channel such that I've got 100 watts into 8 ohms coming out of the right channel, and I terminate the left channel input into a load, or a short actually. And what you're seeing is the leakage from the right channel over to the left channel, and we're getting at least 60 dB of isolation or crosstalk separation between the two channels, which I think is pretty decent. So our first piece of 4 ohm data is the THD SNR plot at 1 kilohertz, and we've got roughly about 200 watts into the 4 ohm load. And what's interesting is that both channels are much more balanced than they were at this high a power level into 8 ohm loads. You can also see that the THDs are looking pretty good, as well as the SNRs are in the 80s. Now the SNRs aren't as good as the 8 ohm performance, but overall it's looking pretty good. And here we have the frequency response with the M1.0t into a 4 ohm load and putting out 60 watts a channel. And we can see it's very similar performance to the 8 ohm load case. We do have some ringing in the left channel, and we do see that the channels are much better matched. There's maybe 0.1 dB variation between the left and right channels, and we're seeing a worst case flatness of about half a dB. So here we have the M1.0t putting out a bit over 400 watts into 4 ohms at 1 kilohertz with a THD of less than 0.02%, and the SNRs are in the 80 dBs and the SNRs plus noise are in the 70 dBs. And the spec for 400 watts into 8 ohms was a THD of less than 0.15%. I also should point out that for either 4 or 8 ohms, the gain was specified to be 30 dB for the non-inverting version of the M1.0t. So we're about 29 dB, and we were very close to 30 dB for the 8 ohm load. So it's doing pretty good. And here we have the results from the multi-tone test case for the 4 ohm load, and it shows a slightly less distortion-free range of about 11 bits. And here we have the THD versus frequency and output power into a 4 ohm load for the M1.0t, and it's showing very similar performance as the 8 ohm load did. When we get to the high end of the band, the frequency response of the left channel at 200 watts is a little bit over 1%, and once again the spec limit was less than 0.15% across the entire band. So for the most part it's meeting the 0.15%, at least up to 200 watts. Here we have the M1.0t running as a mono amplifier with a 1 kilohertz signal into an 8 ohm load, and it's putting out 103 watts a channel. And one thing to note is the SNR has decreased in this mode of operation. It is about 63 dB. The THD looks pretty good, and our gain has gone up from 30 dB to about 35 dB. Here is the performance of the M1.0t running as a mono amp at 1 kilohertz into an 8 ohm load, and it's showing 406 watts. Also, the SNR is almost 90 dB, and it's showing 0.21% THD, and we're also running about 35.5 dB of gain. And our last piece of data shows the harmonic level for the M1.0t operating at 400 watts into 8 ohms as a mono amp, and you can definitely see here that the odd harmonics are much higher than the even harmonics. So after all of the measurements that I made on the M1.0t, I hooked it up to the KEF 107s and used my Carver C1 preamp as well as my Surfans music player to listen to a variety of music for about an hour. I thought the amplifier sounded great. I punched it up to where I had 6 of the 7 LEDs lit and hit SPLs of 92 dB, which was very loud, and as my wife was home I really couldn't go louder. The unit sounded fine. Also, it does not really get warm for a power amp. I measured the temperatures at a couple different spots, right here and right here and right here and right here, which are the ends of the case by the heat sinks. And the hottest temperature I got was 112 degrees towards the end and maybe 98 degrees here. So it didn't really get that warm after all that listening. When I was doing bench testing, driving 100 watts into 8 ohms for about a half hour, the heat sinks on the back got as hot as 134, which still is not that warm compared to other power amps I've tested. And the front was 107, so 107 towards the front and 134 at the back after half hour of driving a 100 watt 8 ohm load at 1 kilohertz. For most of the listening I did, I was typically hitting between 1 to 4 on occasion LEDs, and the sound was in the mid 80s for SPLs and sounded just nice. It really sounded nice. There was a lot of bass out of the KEFs, and the highs seem crisp, and I just was very happy with the amplifier. I would definitely recommend this amplifier for a nice amp that runs cool. I have seen some write-ups on these amps running warm, supposedly when they're idling, but my experience is it's only a few degrees above room temperature if it's on and just sitting there. Maybe 5 degrees F above room temperature. So I did not notice the amplifier running warm, and in fact I would say this is one of the cooler amps that I've run. Now I did listen to both the speakers for noise with no signal going in, and I did hear a bit of hum with my ears right next to the tweeter mid-range area, which is typical for most amps with the exception of the Crown amp. Now, as far as using this as a mono amp, from the data that you saw, I would not really want to use this as a mono amp. I didn't think the signal was that clean as a mono amp. And with 200 watts per channel with a lot of headroom from what I saw, this amp should be good for most people with the exception of people having very, very inefficient speakers. So overall, I would give this a 2 thumbs up, and I thank my friend Ian for letting me borrow it, and I was careful not to push it too hard. Once again, I thank you for watching this episode of Vintage Audio Review. If you have not subscribed, please do so. By the time this episode airs, I think we'll be at 100 subscribers, which beats my goal of having 100 within a year. So I'm very happy and thankful to you folks. It means a lot to me, and I like interacting with those of you who do interact on the comments below. So once again, thank you and have a great day or night.